that allows us to see this kind of previously hidden aspect of a galaxy in this amazing detail that was previously inaccessible.
In the vast expanse of the cosmos lies a world of intrigue and possibility. For years, humanity has gazed towards the heavens with wonder, seeking answers to the mysteries that lie beyond our own blue planet. And now, our quest for understanding has reached a crucial moment. Equipped with unparalleled precision and sensitivity, the James Webb Telescope has set its sights on a world that has captured the imagination of scientists and dreamers alike. But what exactly is Proxima b, and why have its secrets remained shrouded in the darkness of space until now? Join us as we explore how the James Webb Telescope just sent in the clearest image of Proxima b yet, the history of James Webb Space Telescope. Billions of years ago, when the universe came into existence, galaxies began to form. Now we have an advanced tool called the James Webb Space Telescope, or JWST. This telescope could help us explore the farthest corners of space. Instead of using regular sight like our eyes, it uses special glasses called infrared to see things we've never seen before. It's like putting on magic glasses and suddenly seeing a whole new world. With the JWST, scientists can study how galaxies, stars, and planets were born. They can even use it to look at planets outside our solar system, searching for signs of alien life. The JWST is a camera with incredible filters, helping scientists capture different colors of light to learn more about what's out there. And guess what? It's made some fascinating discoveries. For instance, it found out that there's even more mass in the universe than we thought, hiding in gigantic galaxies like hidden treasures. So with the help of the JWST, we're unraveling the mysteries of the cosmos, one galaxy at a time. But there is more. James Webb Telescope just announced the clearest image of Proxima b. Back in 2013, scientists made an astonishing discovery. They noticed a tiny pull, like a gentle tug, between a planet and its star. This planet was later named Proxima b because it orbits a star called Proxima Centauri, which is the closest star system to us after the Sun. It's like finding a new friend right next door. Proxima Centauri is part of the Alpha Centauri system, which is about 4 light years away. This means that when we look at it, we're seeing how it was 4 years ago. It's like looking back in time. Proxima b, on the other hand, even though it's just 25 light years away, which sounds far, it's one of the closest planets to us that's outside our solar system. Imagine being able to visit a new world so close to home. Proxima b is a bit bigger than Earth, about 30% more massive. But here's the exciting part. A year on Proxima b only lasts 11.2 Earth days. That's because it's so close to its star, orbiting at a distance of just 7.3 million kilometers, which is way closer than Earth is to the Sun. Meanwhile, you might think it would be scorching hot being so close. But Proxima Centauri is a tiny star that doesn't give off as much heat as our Sun. So what would it be like to stand on Proxima b and look up at Proxima Centauri? Would the sky be a different color? Would the star look bigger? These are the kinds of questions that scientists are excited to explore as they learn more about this fascinating planet. The mysterious surface of Proxima b. Imagine standing on Proxima b and looking up at its star, Proxima Centauri. Instead of a bright yellow sun like we have, Proxima Centauri would look like a big dull red ball in the sky, about 3 times bigger than our Sun. Interesting, right? And if Proxima b is in the Goldilocks zone of its star, which means it's not too hot or too cold but just right, there could be liquid water there. Liquid water is extremely important for life as we know it. But before you start planning your space vacation, there are some things you should know. Proxima b is probably tidally locked with its star, which means one side always faces the star, while the other side is always dark. That's not very comfortable for any living things. Plus, any water on the planet that gets too close to the star would be heated up and turned into steam by the star's powerful radiation. On the flip side, if a planet is too far from its star, it would be too cold, and all the water would freeze solid. Proxima Centauri might not be the best host for life either. Even though it's much smaller than our Sun, its nuclear fusion cores are closer to its surface, causing a lot of chaos and turbulence on its surface. This turbulence creates strong magnetic fields that can produce dangerous radiation and bursts of particles, which would be tough for planets like Proxima b, which are in the habitable zone. Until recently, scientists didn't know much about the magnetic field around Proxima Centauri, but thanks to a new study using advanced maps, we now have a better idea. The study showed that Proxima b gets about 1,000 times more radiation from the star's solar wind than Earth does, which could be risky for any life that might be there. Back in April 2021, Proxima Centauri, the star near Proxima b, had a mega flare, which is like an extremely powerful burst of energy. This flare was a whopping 100 times stronger than any flare ever seen from our own sun. Just imagine how bright and intense that must have been. It's hard to think that anything could survive such a blast of radiation without special protection. While the idea of a planet like Proxima b being a comfortable home for life is exciting, the reality is probably not so friendly. The conditions there would likely be very tough for living things. As humans, we've always been curious about the idea of meeting aliens. Our interest peaked in late 2020 when a strange signal was detected coming from the Alpha Centauri system, where Proxima Centauri is located. What's fascinating is that this signal has a frequency of 982.7 megahertz, which is not the kind of frequency we usually hear from our satellites and spacecraft. Some experts think it might be from a piece of equipment, but others hope it could be a sign of intelligent life out there in the universe. But could there truly be life in such places? Strange life in an intense planet. Recent data from the JWST tells us something exciting about Proxima b. That far-off planet we've been studying might have water vapor in its atmosphere. This is a big deal because water is important for life to exist. Finding out if Proxima b has water or not is really important, like solving a big puzzle in space. Scientists are using all sorts of advanced tools like spectroscopy and atmospheric modeling to study Proxima b's atmosphere from far away. Spectroscopy is like using a special spy gadget to figure out what gases are in the air around the planet. It can help us see if there are things like oxygen, methane, or carbon dioxide, which are all important for life. And then there's atmospheric modeling, which is like building a pretend version of Proxima b's atmosphere on a computer. Scientists can play around with different ideas and see what might be happening on the planet. It's like making a model of a dinosaur and guessing what it looked like when it was alive. By using these tools together, scientists are starting to get a glimpse of what Proxima b's atmosphere might be like, and if it could be a comfortable home for living things. But there's still a lot we don't know, and we need to keep studying and learning more. Even though Proxima b is close to its star, which makes things tricky, we shouldn't give up hope. After all, we have instances right here on Earth of life surviving in extreme conditions. There are tiny organisms called extremophiles that can live in places where you wouldn't expect anything to survive, like deep in the ocean or scorching hot deserts. So if life can find a way to thrive in tough spots here on Earth, who knows what could be possible on a planet like Proxima b? There are tiny creatures on Earth called extremophiles that are like superheroes of survival. They live in places that were once thought to be impossible to survive in, like extremely hot springs, deep sea vents where hot water spews out, lakes full of acid, and even the freezing ice of Antarctica. These tough little guys have shown us that life can exist in places we never imagined. Extremophiles give us hope that life could exist in places beyond our planet, like on Proxima b, a distant planet we're studying. Just like these creatures thrive in extreme conditions on Earth. Maybe there are living things that can thrive in extreme conditions on other planets too. On Earth, we found all sorts of extremophiles. Thermophiles love hot places and can survive in temperatures that would make us sweat. One type, called Thermus aquaticus, lives happily in hot springs, while another, Pyrobaculum fumari, hangs out in extremely hot deep-sea vents where the water is hotter than boiling. Then there are psychrophiles, the cold-loving champs. These creatures can survive in freezing temperatures. For instance, Psychrobacter arcticus is right at home in the icy environments of the Arctic and Antarctic. These extremophiles are like nature's way of showing us that life finds a way, no matter how tough the conditions are. There are other types of extremophiles on Earth that are just as exciting. Acidophiles like Acidobacillus feroxidans love living in places with lots of acid. They thrive in environments that would dissolve most living things. Then there are alkaliphiles, such as Natronominus furanus, which survive in extremely alkaline conditions, almost like living in baking soda. Lastly, there are halophiles like Halobacterium salinarum, which live in places with a ton of salt, like salt flats. These creatures are like superheroes of survival, showing us just how adaptable life can be. Thinking about the harsh conditions on Proxima b, like intense radiation from being so close to its star, makes us wonder if extremophiles could survive there too. Earth's extremophiles give us hope. Take Deinococcus radiodurans, for example. It can survive doses of radiation thousands of times higher than what would kill a human. These extremophiles have evolved exciting tricks to survive, like special DNA repair systems, protective pigments, and unique cell structures. These adaptations give us clues about how life on Proxima b might adapt to its tough environment. Finding extremophile-like organisms on Proxima b that can survive extreme radiation or other harsh conditions would be mind-blowing. It would change everything we thought we knew about where life can exist. It might show us that life can find a way to thrive, even in places that seem impossible to us. But, of course, it's not as easy as it sounds. Discovering life on another planet, especially one as far away and different as Proxima b, is a huge challenge. Scientists will have to use all their skills and the most advanced technology to uncover the secrets of this distant world and its potential for life. How knows? We could as well go to Proxima b. The theoretical concept of traveling to Proxima b, exploring distant planets like Proxima b, is really tough because of some big challenges. Right now, our telescopes, like the James Webb Space Telescope, are exciting at giving us a peek into these faraway worlds. But they can't give us extremely clear pictures or let us do hands-on research because these planets are so far away. To get around these challenges, we need to improve our telescopes and sensors, and maybe even create new ways to travel through space. Imagine if we could develop new kinds of engines that could take us to other star systems much faster than we can now. This would open up a whole new world of exploration and discovery. Scientists are already looking into some exciting ideas, like solar sails that use sunlight to push spacecraft, or ion propulsion that shoots out particles to move forward. There's even talk about warp drives, like in science fiction, that could bend space to travel faster than the speed of light. But these are still just ideas. We need a lot more research and testing before we can use them to explore other planets. Still, it's exciting to think about the possibilities. Maybe one day, we'll have the technology to visit places like Proxima b and see what secrets they hold. The complex path to Proxima Centauri b. Imagine being able to travel to Proxima Centauri, the closest star system to us, and meeting aliens. It might not be as crazy as it sounds. Scientists at the Breakthrough Initiatives are figuring out how to make the journey shorter, from hundreds of years to just a few decades. One big challenge is making sure a spacecraft can keep speeding up as it gets closer to the speed of light, which is extremely fast. Right now, with our current technology, it would still take about 6,000 years to get to Alpha Centauri, the star system that's part of Proxima Centauri. The Starshot project has an exciting idea to use lasers to push a spacecraft toward Alpha Centauri. But here's the tricky part. Earth's atmosphere can mess with the lasers, making it hard to give the spacecraft the right push. Bandhu Tunga, the lead scientist, thinks we can use a special tech called adaptive optics to fix this. Small lasers on satellites would check the atmosphere in real time, helping bigger lasers on the ground stay focused on the spacecraft. These lasers need a ton of power, like all the electricity used in the whole United States, but they only need to be incredibly powerful for a short time. They plan to use 100 million lasers, spread out over a big area, to send the spacecraft on its way. Once the lasers are turned off, the spacecraft will be zooming through space at an incredible 20% of the speed of light. It would be about 10 meters wide and could reach Alpha Centauri in just 22 years. That's faster than a lot of people's lifetimes. When a spacecraft travels to Alpha Centauri, the closest star system to us, it faces some big challenges. First, the pull of the sun and debris in space could slow it down a lot. Even if it reaches Alpha Centauri, it would take another 4 years for its messages to reach Earth. That's like sending a letter and waiting years for a reply. Scientists like Bandhu Tunga and Sibley are working hard to make sure the spacecraft doesn't melt on its journey. They need to make sure the mirror on the spacecraft is nearly perfect, reflecting almost all the light that hits it. They also need to make the spacecraft change direction and slow down quickly to avoid overheating. One of the most interesting parts of this idea is that once they figure out how to launch one spacecraft, they can send more at a reasonable cost. This means they could explore many star systems and increase the chances of finding planets like Earth. Just imagine the possibilities. If we reach Proxima Centauri, we will have a whole new star system to explore. Who knows how many planets like ours might be out there waiting to be discovered? Scientists have already found thousands of exoplanets, which are planets outside our solar system. They made their first official discoveries in 1992, finding planets around a special type of star called a pulsar. 3 years later, they found a planet orbiting a star like our Sun. Since then, they found many more planets, including some that are similar in size to Earth and orbit in the Goldilocks zone of their stars, where it's not too hot or too cold for life. It's an exciting time for space exploration, but you can't be more fascinated by how the JWST discovered this planet. How did the JWST make the discovery? The James Webb Space Telescope is like the superhero of space gadgets, stationed at a spot called the Second Lagrange Point, or L2, which is about 1.5 million kilometers away from Earth. That's like traveling around the Earth more than 37 times. Being at L2 helps the JWST stay in a steady orbit as Earth moves around the sun. It's like finding the perfect spot to watch a parade without getting jostled by the crowd. Equipped with all sorts of incredible tools, the JWST is designed to uncover the universe's deepest secrets and solve its biggest mysteries. One of its main jobs is to hunt for exoplanets, which are planets outside our solar system, and see if any of them are similar to Earth. And you know what's most exciting? It's going to take a close look at Proxima b, that mysterious planet we've been talking about. The JWST can take pictures and gather information using different types of light, especially infrared light, which is like a secret code that helps us see things that regular light can't. Its main mirror is made up of 18 hexagon-shaped pieces and is a whopping 6.5 meters wide. That's taller than two grown-up people standing on top of each other. This big mirror helps the JWST take incredibly clear pictures of exoplanets like Proxima b, much better than any telescope before it. These interesting features of the telescope help it see things that are far away and incredibly faint. Imagine trying to see a firefly twinkling in the dark from far, far away. The size of the telescope's mirrors is extremely important because it helps gather even the tiniest bits of light. This makes the telescope much better at seeing things in space, like the first stars and galaxies that ever existed, or even the faint glimmers bouncing off exoplanets. The James Webb Space Telescope is capturing these tiny bits of light and putting them together to make a clear picture for the first time. But here's the thing about exoplanets. They're not like stars that shine on their own. They're more like mirrors that reflect the light from their stars. They're so small compared to the vastness of space that they look like little dots, just like stars do when you look up at the night sky. We wouldn't even know these exoplanets exist if it weren't for two special things. First, when they pass in front of their stars, they make the stars look a tiny bit dimmer for a little while. It's like a mini eclipse in space. Second, they tug on their stars just a tiny bit with their gravity, which makes the stars wobble just a bit in their orbits. It's like a cosmic dance between the planet and its star, and we can catch them in the act thanks to telescopes like Kepler. Kepler, another space telescope, has been working hard to spot these wobbles and mini eclipses. It's found hundreds of exoplanets during its time in space. Until now, we haven't been able to take a close look at the area around Proxima b, that mysterious planet we've been talking about. But guess what? Now with the JWST, we're about to change all that. The JWST is like a superhero telescope with 4 awesome tools: a near-infrared camera, NIRCam, near-infrared spectrograph, NIRSpec, near-infrared instrument, NIRISS, and mid-infrared instrument, MIRI. These gadgets are going to help us see things in space like never before. These tools can see light from all over the place, even from far away or dark places in space. And you know what's interesting? They can even see different colors of light, from the ones we can see with our eyes to ones we can't see, like infrared light. This special light can help us find out what's in the air around exoplanets, like Proxima b. We might even find clues that tell us if there's water or oxygen there. The NIRCam is like the main camera of the JWST, and it's perfect for watching what happens when a planet like Proxima b passes in front of its star. It's like taking a picture when a bird flies in front of the sun. This camera can help us learn about the atmosphere of Proxima b and how it might be different from Earth's. The NIRSpec is an incredible tool because it can split light into different colors, like a rainbow. By looking at these colors, scientists can figure out what a thing is made of, how hot it is, and other important things. This will be useful for studying the air around Proxima b and searching for signs of life. MIRI, on the other hand, can see light that's a bit warmer than what the other tools can see. It's like having a special heat vision power. And you won't believe this. MIRI might even be able to spot signals of artificial light coming from Proxima b. That's like finding a secret message in the stars. While MIRI might not be able to spot a single light bulb shining in an alien's home or the bright lights of big cities or industrial areas, it's still an incredible tool. When you combine MIRI with the other tools on the JWST and its huge mirror that gathers lots of light, you get an incredible telescope. It can see tiny details on exoplanets like Proxima b, and maybe even find signs of artificial lights or other clues that intelligent life might be out there. This is a huge leap forward in our quest to find out if we're alone in the universe. Another milestone for human history and discovery. Proxima b is like a stepping stone that helps us understand more about planets far, far away. It's a small step that opens up big possibilities for exploring the universe. But Proxima b is just one piece of the puzzle. There are many types of exoplanets out there, each with its unique features and potential for life. Some exoplanets are like giant balls of gas. similar to our hot Jupiter. Others are rocky, similar to Earth or Mars. There are even super-Earths, which are larger than our planet, but smaller than Neptune. Each of these planets offers a different glimpse into the diversity of worlds beyond our solar system. Telescopes like Kepler and the JWST have been crucial in this exploration. Kepler has identified thousands of potential exoplanets, giving us a glimpse of the variety of planets out there. The JWST, with its advanced technology, has taken us even further by helping us understand the atmospheres and compositions of exoplanets like Proxima b. Thanks to these telescopes, we now know more about how planets form, the conditions that might support life, and the diversity of planetary systems across the cosmos. This knowledge is not just interesting, it's also important for guiding future space exploration and expanding our understanding of the universe. Beyond exoplanets, the JWST has made other exciting discoveries. It has helped us see distant galaxies in their early stages, giving us insight into how galaxies form and evolve. It has also shown us more about how stars are born and how galaxies come together, deepening our understanding of the vast universe around us. The James Webb Space Telescope has an incredible ability to see far, far away into the universe, showing us things we could only dream of seeing before. It can look through cosmic dust clouds and capture the faint light from stars that are billions of years old. With this exciting telescope, scientists can learn about how planets form, what the atmospheres of other planets are like, and even how black holes behave in galaxies that are very, very far away. By using the JWST, scientists have not only found answers to questions they already had, but they've also discovered new things to wonder about. This telescope is like a window into the universe, giving us a deeper understanding of space and everything in it. In the future, the JWST will help us learn even more about the early days of the universe. It will show us how galaxies formed and give us more clues about how life might have started. It will also help us study planets outside our solar system, called exoplanets, and explore galaxies that are so far away we can barely see them. One of the most exciting possibilities is that we might soon discover life on another planet like Proxima b. If we do, it will change everything we know about our place in the universe. Finding life on another planet would show us that life is not just something special to Earth, but something that could be found all over the universe. This discovery would lead to new and exciting advancements in science, helping us understand more about life, where it comes from, and how diverse it can be in the universe. Discovering life on another planet like Proxima b would be an incredible moment in human history. It would make us think deeply about our place in the universe. We might start to think about what it means to be human and how we relate to other forms of life. This discovery could lead to conversations about what responsibilities we have to other beings in the universe. Finding life on another planet could also inspire us to think differently about our values and ethics. It might encourage us to work together as a planet rather than as separate countries to learn more about this new life. This could lead to exciting advancements in how we communicate with each other and with other species. Discovering life on Proxima b could also change the way we think about art, literature, and media. We might see new stories and ideas about space exploration and what it means to be part of a larger universe. This could inspire young people to pursue careers in science, technology, engineering, and mathematics. However, finding life on Proxima b would also bring up some big questions. We would need to think carefully about how we interact with this new life and what impact we might have on them. This would require us to consider the consequences of our actions and how they might affect both our civilization and theirs. The discoveries made through the James Webb Space Telescope have opened up new horizons in our understanding of the universe. We've learned about the birth of stars, explored distant galaxies, and uncovered the mysteries of planets beyond our solar system. This telescope has been like a window into the vastness of space, showing us things we never knew before. The impact of the James Webb Space Telescope on our exploration of the cosmos is huge. It has helped us understand more about planets like Proxima b and has allowed us to study ancient galaxies. Its discoveries have advanced our knowledge of the universe in ways we never imagined. Let us know what you think about what JWST released about Proxima b in the comments below. And if you enjoyed watching this video, make sure to give it a like and subscribe to the channel.